High School in Louisville, Kentucky, and we're conducting a workshop here today with our math department. So it's after school on a Tuesday where we normally meet as our professional learning community, and now we're meeting together as a department. And we're going to focus on the second critical question. Our PLCs actually worked earlier today on the first critical question. The second question deals with how do we know when they have learned it? And going back to what that first critical question is and what do we expect students to learn, we know that we're there as a school. As I look across this room, I see learning targets that are attached to standards, and I see standards-based grading, and I was just in a PLC where we talked about common formative assessment. But now we need to talk about what do we actually do to know whether they have learned it or not. All right? So lots of times when we meet and as a PLC, we just see this mass of numbers that are in front of us. We scan in our material through GradeCam, and we get just get this mass of numbers. One of the things that is an expectation here, of course, at Fern Creek is that our assessments are aligned according to standards. So this is a proficiency exam that we have lined up with two standards. We have slope on one side for the first three questions, and then we have quadratics on another. You all are sitting according to your Algebra 1 PLC, your Geometry PLC, and Algebra 2, okay? And this is just one teacher's data. But I want you to sit and think about for a couple minutes, what do you do when you see a whole set of data, all right? I'm going to come back and call on you by PLC on how you handle looking at whole group data. You have 2 minutes to think about it. Go.
I usually calculate based off who I know had a choice. You always got to kind of take the outliers out the bottom, but I know some people take the outliers off the top too. Try to get a good percentage there.
I may teach it in a way, how are you doing the guessing?
Well, so I noticed that quadratic as a whole was lower, but then like raising it specific questions, what would make some more than the others? So like the last slope question was the lowest slope, so what are they missing on that last question?
We talked about it yesterday.
1 minute?
Especially that last question, the quadratic is quite a bit lower than the other two, so what's in that third question?
Like you're doing
Like that first quadratic question,
Exactly.
all answers were picked, whereas like the last two.
ratio,
One
prime
that they
ratio.
weren't picking, so
Yeah, and I was doing just the
Can you blank, like, are they
radical.
counting that as a zero,
Well, I
or
was
just
making
not
almost
averaging that
so
one in?
like last month, I don't want to know they want to
See, I would probably take that
last month,
chance.
I want to know the radical.
But at the same time, if you look at mine, I don't know if they did.
All right, we're going to bring it back at 15.
I don't like looking at my hand. You can't get it right. You can't get it right if you don't try. But you're definitely going to get it wrong.
All right. So did you all have agreement amongst your PLC about how to take a look at this? Was it good discussion? That's good. All right, part of what we're trying to do is calibrate how we work as a PLC. So if there was a lot of positive discussion, a lot of agreement, that means something about your PLC. It means that when you look at a large set of data, that you have some common ideas with it. So we're gonna begin with Algebra 2 here and talk about it. So you get this big data sheet. So how do you know whether they learned it or not? So I need somebody from Algebra 2 to speak up.
Well, we said we noticed out of the two standards as a whole that slope, they seem to do better on slope than quadratics, and then we kind of narrow in on the questions what hung them up on certain questions and why. So
Okay.
we would look at that data.
Let's go to geometry.
We were looking at, were there any like distractor answer choices? So like in slope, we noticed that on the second one, they were either picking B or D. So why was it that those students were picking D when they should have picked B?
Okay. All right. Algebra 1.
What we discussed was how when we normally analyze like proficiencies or diagnostics, normally on 75% of the questions, we're about 4 to 5 points away from each other, but we look at the ones that like, there's outliers, like maybe mine, I get like 20% and Brian gets like 50%. So I like to compare what he did differently on a certain question or what I did and to help the kids and maybe just combine our thoughts to give the kids the best shot.
So when you take a look at there's a lot of things that you have to consider. And obviously this isn't your test exactly. So just me as an administrator, I come in and look at this. I would have a lot of questions about what these numbers mean and how things were taught. So here's some important reference points when it comes to looking at whole group data, all right? And your answers really illustrate this first one, is analyzing the overall student strengths and weaknesses that you see within it. So within it, what did they do better with, slopes or quadratics? Slope. They did better with slope. But here's the other part that we need to ensure that we're getting to as a PLC, and this was talked about, but the lesson plans and activities. So as you go back and you're looking at, all right, so they didn't score as well as a whole class on quadratics. They did better in slope. How does this reflect the lessons and activities that we did? How does this affect the types of questions that we ask them dealing with those? And what about, not just type, but the higher order skills in terms of the activities with the questions with it? Was it multiple choice? Did they have to show their writing? There's a lot of variables within that. The final component, when you look at whole group, is this 80% threshold, okay? 80% threshold. And what this essentially means is that when you're teaching a standard, and this frequently happens probably with most of our assessments here at our school, and you can tell me I'm wrong, but the first time you do a whole group proficiency exam, how often do our kids, where 80% of our kids get 80% or more questions right, or show competency? How often does that happen? Barely?
Yeah.
So what that means as a PLC, as teachers, we know we're going to have to go back and do whole group reteaching of that. And this is where your PLCs come in, where you're talking about the time consideration. Is this an immediate reteach? Is this something that we're going to build as part of our pacing over time? If we do that, how will we reassess? But this 80% threshold is very important. So on the example previous, there was, students did well enough on slope where really whole group you would be able to go on. But when it came to quadratics, you would have to do a lot of whole group reteaching that's associated with it. So, and again, as we go into questions 3 and 4, we talk more about the RTI process. But when our class is struggling, we have to have an intervention plan in place. So that's how we look at that wide group of humanity when it comes to those questions. So now, let's change it to how do we know when they learned it? And there should be a picture of Shayna here. To how do we know when she has learned it? So what I've done is I pulled out a data tracking sheet from Algebra 1, and I filled in a couple of the numbers here. Because now as a PLC, we're asking a different question. Or as a teacher, we're asking a different question. Getting down to now Shayna and her data tracking sheet, okay? So we have slope here, all right? And this is her data tracking sheet. It's out of 4, okay? So when you see A 3, that's a 3 out of 4 on that standards-based scale that we use. A 2 out of 4, 3 out of 4, 4 out of 4, and a 3 out of 4. So I have just a couple questions for you as a PLC as a result of this. Is on this right here, standard 6 and this y equals mx plus b, do you think Shayna is red, yellow, or green? That's the first question. And second is, what interventions would Shayna need as a result of it? And again, if you think she's green, well, I guess you wouldn't need an intervention, but take a look at it. Within your PLC, what do you think? Is she red, yellow, or green? If she's red or yellow, you know, what type of interventions would she potentially need? We'll give you about 90 seconds to think about those questions.
Well, and that would make us see her work and figure out, like, there's something that she's caught up on, why it doesn't make sense.
That's why it's supposed to be really good.
Yeah, just the one.
Yeah, right.
Which is this.
Three out of three. Yeah.
So is that red, yellow, or green?
Maybe all they did is a little connection. Connected to something that's not clicking for all of it.
Well, it depends on what they mean by it.
Forgot it, it's just so much.
I don't think
That's what, I'm doing right now, like,
Crazy.
we probably got the same equation here.
That's what you want.
It's a 75.
Right, yeah. But that would mean that they truly only got 75%. I think correct, that's why I want something towards it between. Because there's such a big gap between. Huh?
Do you do like a 3.2?
Yeah, I do everything, yeah.
30 seconds.
It's too much up and down, up and down, up and down, or something.
And so to remediate, you look at the work to try to figure out what the misconception is.
And there might be some small mistakes.
Right.
Like, forget
Right.
All right, let's come back to this. So the first question we asked, and we'll go ahead and begin with geometry this time, is Shayna, and again, you also have the dates underneath there, but is Shayna, is she red, yellow, or green in geometry?
We said she would be more green.
More green, okay?
Yeah.
And what's the
Green, but
rationale?
closer to the green. I'm sorry, what?
What's the rationale on why Shayna is green?
Well, because, from the first check, she was at a 3, which was a yellow, and then she went down, back up to a 3 and a 4, so she showed improvement. And then on that last one, got a 3, but that could have just been, maybe she added when she should have subtracted. So at one point, she was mastered.
So I think it's important, again, let's think about how we look at this as a math department. A 3 means what? On the 4-point scale in math, a 3 means what?
Proficient.
Okay.
Yeah.
Typically, 3, the 4 is a distinguished, a 3 proficient, 2 apprentice, 1 novice. So, all right, so you said green. Algebra 2.
We said more yellow because
Okay.
she is kind of fluctuating quite a bit, and I think we use 3s in different ways.
Okay.
So like in my classroom, like a 3 is a 75%, so I think it depends on what you mean, by what percentage.
Okay.
But we also said we'd want to see her work because it seems like there might be just one thing